Our next speaker wants to draw international attention to Norwegian shores and make them see the huge potential for offshore wind in the North Sea. Olav Giæver Tande is director for the Norwegian Research Center on Wind Energy and chief scientist at SINTEF, a Norwegian research foundation working on technology for a better society. And one question then could be, could the Norwegian continental shelf provide Europe with clean offshore wind power and in that manner make it less fossil fuel dependent? And another one is, what is the potential for both floating and fixed offshore wind? And will we see lower costs soon for this energy source? Olav, he is one of the most knowledgeable scientists in Europe on offshore wind, and it is a pleasure to welcome him on stage. You're here already, so we can now lean back and get some of the knowledge that he's ready to share with us. So Olav Tande, the scene is yours.
Thank you. Happy to be here. I realize this is the first session after the lunch, and now it's been 1 hour, so people are starting feeling maybe a little bit, is it the break soon? Where's my coffee? Well, I'll try to make it short and interesting. So I'll talk about the North Sea as a springboard for the green transition, and why is that? The North Sea is well known for oil and gas activities. It's well known for fishery. It's well known for transport of goods. And lately it's been a development place for offshore wind. For the last 2 decades, offshore wind has been a major development in the North Sea. And I would claim the North Sea is the ideal springboard for the green transition, not only for offshore wind, but also for developing oil and gas activity into a more green activity, also with hydrogen production and with CCS. But I will focus my presentation on offshore wind. And offshore wind is, put simply, a giga opportunity. Europe has set clear targets for offshore wind. So the European Commission has set 300 gigawatts of offshore wind by 2050. The UK has said 100 gigawatts of offshore wind by 2050. Norway has said 3 gigawatts. But it's likely to be more. So my guess is 450 gigawatts of offshore wind by 2050 is realistic. This will supply 1/3 of the electricity demand in Europe in 2050. And it will make offshore wind the backbone of the energy system in Europe. That's not an easy task, because you know that the wind varies. So you need to have a strong grid to connect the offshore wind to the consumers and to level out variations. But you also have to make this grid to transport not only electricity, but also hydrogen, which is also very important to provide flexibility. And then I have a picture here of a floating wind turbine. And what's that important? Why is that important? That's important because 80% of the global offshore potential is floating. It is on water depths greater than 60 meters. So if you want to exploit water depths, offshore wind globally at greater water depths, you need to develop floating wind. But floating wind is only 1% or less than 1% of the global wind capacity installed today. Today in Europe it's about 25 gigawatts of offshore wind. Globally it's about 35 gigawatts. And floating wind is currently less than 100 megawatts. So there is some development to be done. Bottom fixed wind can be installed and operated at a cost around 50 euros per megawatt hour. Floating wind is a cost about double that, but it is because it's an early stage development. It can, and I'm quite confident, will be more cost efficient than bottom fixed once you get the development up to scale and you've done the research and innovation that is needed. So this is important. Development of offshore wind is essential to reach climate targets, to secure affordable energy supply, and enhance a competitive industry. So I guess now you're all thinking, this is great. I'm sure everyone is developing offshore wind as fast as they can, and it's really push, push, push. It is an ongoing development. 25 gigawatts is developed already. There are more in Europe alone. There are more plants being built as we speak. Dogger Bank is the biggest one that is being developed. It's 3.6 gigawatt. In the UK, connected to the UK with 2 HVDC lines. In Norway, there are 2 fields that have been opened. One in southern North Sea, that is SN2 on the slide, and the other one is on Utsira Nord, that's floating. That's the field named UN in this slide. And these 2 will supply 3 gigawatts in total. ScotWind recently announced results of the bids. They will have 25 gigawatts of offshore wind developed, ScotWind round, and 15 of those will be floating. So there is a strong development. But these are things in planning, and they will likely not be online before 2030. That also holds for ScotWind, I'm afraid. So we need to speed up. And here I have maybe a controversial suggestion, and that is to piggyback on oil and gas. Because in Norway, oil and gas stands for 25% of the CO2 emissions. So, in order to cut emissions in Norway, we have 2 options. Either we can stop with oil and gas activity altogether, or we can make the oil and gas activity without CO2 emission locally. And you can do that by supplying the electricity for the platforms by offshore wind instead of using gas turbines, which is currently the case. So then you can have, as is done today on a project called Hywind Tampen in Norway, there's an 88 megawatt wind farm being built close to an oil and gas platform, and that will save about 35% fuel. But that is just connecting the oil and gas farm platform to with the wind farms and isolated system. Then you can add an energy storage and you can increase savings, or you can connect it to the grid and you can have the offshore wind farm and the oil and gas platform connected to the grid, and that will save 100%. And it also has the benefit that you can keep on running the offshore wind farms after the oil and gas platforms are stopped in operation. So, three steps for a green transition. We can reduce the CO2 emissions from the Norwegian continental shelf through use of offshore wind and connection to shore and possibly other solutions. You can also use natural gas and produce hydrogen with CCS for the oil and gas platforms to transfer them to being a source of hydrogen. And offshore wind can of course continue to supply clean energy after the oil and gas activity is stopped. So I claim again, the North Sea is an ideal springboard for the green transition. We need development, we need deployment, research and innovation to succeed. It's urgent. We need to have CO2 emissions cut to zero before 2050. And we need to do it sustainable. So we need to take care of nature, we need to engage with the public, and of course we need to do it public knowledge-based. You can read more about this in this report, and that was presented also at COP26 in London last year. Thank you.